Hello once again. Now we will now try binomial test. But before that, i-analyze muna natin yung assignment nyo last video on one sample t-test. Here, we're looking at seagrass shoot density per square meter. So, hindi na ako magsi-step by step sa hypothesis testing para rekta na. So, I assume na alam mo na rin yung gagawin after you have watched that tutorial. So, first, normality test muna tayo. Analyze, non-parametric test, legacy dialogues, one sample Kolmogorov-Smirnov. Okay, click OK and there you go. P-value is 0.2, which is greater than 0.05. This tells us to accept HO that the data is normally distributed. So, pasado sa normal distribution. Next, mag one sample t-test na tayo. Analyze, compare means, one sample t-test. Then we transfer our variable of interest here. As I've said, our global value for seagrass shoot density is 450 shoots per square meter. So, let's put it here. 450. Click OK. And in the table here, our sig two-tailed value or p-value is 0.003. Now, since this is less than 0.05, we have to reject HO and claim that the average seagrass shoot density of our sample is not equal to 450 per square meter. If you check our descriptive stats table here, we have a mean of 461.5667. Therefore, or maybe we can conclude that yung seagrass shoot density in our area of interest is higher than the global value, which is 450 shoots per square meter. So maybe this can tell something about the abundance of seagrass in our area. Okay, we're done with the assignment. Ano na naman tong binomial test? Now, this is to test whether the percentage of our observations is greater than or equal to some proportion. For example, in this data set, you check the gills of 50 Nemepterus fish. So, this is locally known as lagaw or bisugo in Tagalog. Then, you detected microplastics in some of them. Okay, you want to find out if your observations are consistent with, shall we say, findings from a local journal stating that almost 70% daw ng population ng mga isda have microplastics in their gills. Now, on our guide, yung requirement lang naman to perform this test is that dapat dichotomous yung variable nyo. Nominal data, and again, expressed only in two ways or observations. In this case, microplastics or wala sa gills. So, back to hypothesis testing tayo, guys. First step again, you state the null and alternative hypothesis. So, our HO should be like this. The percentage of Nemepterus sp with microplastics in their gills is equal to or greater than 70%. Siyempre, ito yung sabi sa news based on a recent study. But again, you are skeptical. Nag-worry din yung mga nagbibenta ng isda na baka bumaba yung kanilang sales because of this finding. So, you need to check kung totoo ba talaga yung claim. Otherwise, kung hindi pala totoo, our alternative hypothesis is that the percentage of Nemepterus sp with microplastics in their gills is less than 70%. Next, as usual, you choose the level of significance and sample size. So here again, it's 0.05. Our N is still 50. 50 samples. Then we determine the test statistic. So we have chosen binomial test. For the critical values, it's still P is greater than 0.05. Okay. Accept HO if P is less than 0.05. Reject reject HO if your p-value is less than 0.05. And 5, you collect data and compute the test statistic. So it's all here, and I'm doing the computation right now. So let's compute. Click on Analyze, Non-Parametric Test, Legacy Dialogues, and you have here your Binomial Test. So ilagay natin tong variable on microplastics as our test variable. Our test proportion is of course 0.7 or 70%. Kasi nga yan yung claim na 70% ng population ng mga isda may microplastic sa gills. Click OK. We now have the output table and our sig value here is 0.001. And again, this is less than 0.05. So, ano yung gagawin natin? We reject the null hypothesis that more than 70% of our sample has microplastics in their gills. Halata naman siguro, right? If we look at the table here, only 24 out of 50 have microplastics. So meaning, mga more or less 50% lang pala yung mga may microplastics, not 70% as claimed. Okay? So decide again. You reject HO and you state that the percentage of Nemapterus sp with microplastics in their gills is less than 70%. So I hope that was helpful. Assignment ulit yung included na dataset. So let's check it here. This is about coral colony species richness. Again, a word of advice lang po. So it's important that naiintindihan nyo yung problem before you start analyzing data. Because what we're doing right now, hindi po ito drill na pindot ka lang ng pindot ng analyze. So you really need to analyze the problem. So first, define muna natin yung species richness. Okay? So of course, this is the number of species in a given area. So wala tayong pake kung gaano karami per species. Isa man yan or 1,000 per species, we count it as one species. So kung merong 50 organisms, plant man yan or animal, that will tell na ganyan ka-rich ang species in an area. So in this data set, dichotomous pa rin. Because here, yung nilagay lang is low species richness and high species richness. Now, yung coral colony naman ay, this sounds like area po lamang. So, where your species richness is observed. Obvious naman po siguro ang term na colony. So, it's an aggregate of coral polyps and of course, their skeleton. Now, since nagsusupport ito ng life, pwede mong i-check ang isang colony and observe kung mataas nga yung species richness dito. In a reef, for example, you can have lots of these colonies na pwede mong i-survey. Now, assuming ulit, sa climate change reports, yung species richness daw ay bumababa in coral reefs in your area. So, you want to test if this is true. Okay? But of course, you have to set a point of reference. So, let's say, sabihin na natin 50%. Pag mababa yung 50% ng mga coral colonies natin ay mababa na yung species richness, then we can say na mababa na yung diversity in that area. So now here we have the data after surveying the area. So it's now your job to perform binomial analysis to establish na kahit paano yung coral colonies has still high species richness. So, see you sa next tutorial. We will answer this problem there. Bye!